morning, Dave Snyder here. Today is September 3rd, 2013. I want to start this video off showing you this picture of Building 7 from 9/11. And I want you to take a good look at how it's all piled like that. And look at the middle of the pile. Look at this. This is a perfect demolition. Perfect. I mean, I'm not an expert, but I can see that that's exactly how, if I was going to bring a building down, that's exactly how I'd want to pile up, just like that. I mean, that is so perfect. They must be real proud of themselves for that one. But look at the middle of it right here. See how that is right there? Remember how it kinked in the middle and fell straight down? That's exactly why it kinked in the middle. Look at the middle of it. You see that it's all busted. They blew out the center of it, and it all fell towards the center, and it all just laid right down. All the sides laid right over the pile, just perfectly. That's just, and no plane hit the building. No plane hit it. Just fire did that. Just fire supposedly did that right there. And you can see the center of it right there. Exactly. That's exactly how you would do it. I mean, when Silverstein said pull it, that's exactly what they mean. They would pull it to the center, and it piles right up just like a nice little pile of scrap, ready to haul away. So there you go. I wanted to remind everybody of that. Let's not forget about 9/11. It seems like everybody's pretty much moved on from it. I don't think we should. I think we should basically keep our mind on that somewhat, because it just shows what people are capable of. People that run this country are capable of, basically. Okay, so on to the usual stuff here. I want to show this video again that I made a little while back. I want you to notice the weather patterns right here, this weather pattern right here. When I show you this video, I'll just show it for a minute, and then I'm going to pause it when it hits this point. So I'm going to shut up right now so I'm not talking over the video. All right?
Hi, Dave Snyder here. It is the 5th of July, 2013. Got something
This also created the Rocky Mountains
here. This is the weather on the Earth at this very moment. Okay, let's just make sure it's up to, I mean, it doesn't matter if it's up to date or not, really. Let's just make sure, all this very moment. Okay, let's just make sure it's up to, I mean, it doesn't matter if it's up to date or not, really. Let's just make sure, all up to date. 5th day, July. Okay. What I did is I did a little readjustment of this crater that I had up here, called the mother lode, and it was centered in the mother lode at one time, but I've readjusted it since then. Here we go. I just actually readjusted this just a half hour ago. Okay. And I was just, I know this weather pattern. See, what I lined it up to was this right here. This edge. See this edge? Watch this. Watch the weather.
All right, now check it out. Watch this weather fit this pattern so well.
You know how that weather fits around that little curve right there? Now, I think it goes with this curve right here. Now, this is, and you see how the inside of this fits. But this crater, Narrow Oriental Basin, this picture right here is a little bit different than we see it on Google Moon. I believe that this one is more accurate. But then again, it's really hard to say, because when you pull up what I did is I took the image from Google Moon. The moon served this crater from the Google Moon. And check this out, people. Just watch this. You see how this weather all fits in there so well, like this, right? I mean, all the way around it. Take that picture off. Bring up the Narrow Oriental Basin from Google Moon. Look at the weather. Look at the shape. Watch this.
Okay, you see that? See the center of Narrow Oriental Basin on Google Moon? See how the shape is right here? This is overlaid right over the Rocky Mountains, directly over the Rocky Mountains. Now, if you look up, just Google this, look up Rocky Mountains created by giant sucking action. There's an article that says where the scientist has a theory that it was created by some kind of sucking action and the mountains were pulled up. Right? Okay, so this weather pattern was, I saved this a while back. This is a video I made at least a month and a half ago or so, and probably 2 months. And you look at the shape of the center of this crater. Look at this. See that? See what they do? See how it's turned this way? Now, what? Okay, so
I
anyways,
have
you've seen that. So it lines up with the center of the. Let me bring that back up again. It lines this picture of Mare Oriental from Google Moon lines up with the center just perfectly. I mean, it shows that it lines up with this one. And the other picture right here, it shows this right here
this
lining up
picture right
perfectly.
here is a little bit different than we see it on Google
Back
Moon.
it up a
I
little bit.
think that I believe
Right here.
the basin.
Look at this.
Now,
Look at that.
I think it goes with this curve right here. Now,
So, anyways,
and you see
I
how
wanted to point that out because I think that's pretty important right there. I don't want this video is getting kind of it's got a 490 views, but I mean I just want people to see that again. I want you to realize that the Rocky Mountain. This is directly over the Rocky Mountains, directly over the Rocky Mountains, and they say that there was an inland sea right there where the Rocky Mountains were. Okay, and now what we have left over that inland sea basically is the Great Salt Lake, right in the center of that impact, where the Mare Oriental Basin was right up, the center of it was right over here. That weather pattern was right here. So when they say that it was created by a giant sucking action, I believe he's right on the money right there, because what happens is it hits right here. I guarantee that crater hits right there. Look at the roundness of this area. Look at the circular shape of the whole western United States. Okay, hits right here. There's an inland sea there when it hits, and when the moon pulls away, eventually, it sucks up it pulls the Rocky Mountains up while it's separating from the Earth. That's my theory. I mean, the weather basically proves it. I mean, there's no question the weather shows that exact same thing. So, anyways, I want to point that out. You can check that out all yourself. Just pay attention to the weather. I mean, that was a while back, so the weather's a little different now, but it'll still line up right there. You still see the roundness of everything. Everything's round. I know the Earth is round, but I mean, just saying. Okay, so what next? Let me see. What's we got here today? Kind of outrageous weather patterns. All these weather patterns are from moon impacts, showing moon impacts, but they just show them differently at different times. Different times of the year, you'll see them show up pretty good. This is not one of them times of the year, I don't think. Antarctica. Antarctica is a direct impact from Mare Oriental or something like that. It's the south pole of the moon directly impacted. You can line that up with Mare Oriental just perfectly. I've done it before. I got videos up about it. You can check my channel. Go way back and you'll see North Pole, South Pole, both impacted by the moon. Okay, so what I'm going to show you now is I don't know. This is probably I saved an image of the North Pole, and it was probably I don't know 4 months, 5 months, maybe longer. Okay, let me show you that right now. Just pull it up here. I got it overlaid in Pacific. I got to grab it real quick. Right here, I think. Okay. Hold on. Right here. Okay, this is the weather at the North Pole. And you can see it's marked right here, North Magnetic, right here, North Pole, geographic. And you can see the Arctic Circle basically in the weather pattern. Here's Greenland right here, okay? And you can see that basically this Arctic Circle, it comes down into Canada here, and it's a big circle, right? Well, the pole's centered right here. This is the geographic, and this is the North Magnetic, so it's right in that area of the North Pole. I mean, it's pretty well aligned there. I mean, this is their picture, right? The picture of the weather that day, and it's hard to get a picture of the weather at the North Pole without these always being in there somewhere. They use these areas like this. Sometimes you'll see them small like this. Sometimes you'll see big ones. When you see the big ones, they're basically hiding patterns in the weather that show lunar surface. Basically, prints of the lunar surface that are really obvious. They don't like to show that on Google Earth. They will put those big triangle things, weird shapes up there at the pole. I mean, there may be some there right at this moment. I don't know. Check it out real quick. Usually there is. I mean, if there's nothing to hide, they won't have them there. So it's like the satellites work sometimes they don't. You know what I mean? So there's not much. Obviously, there must not be much to show up there today because you're not hiding anything. Okay. But when there is something, they will put those there. So like the this, like I said, the satellites must be just intermittent, right? Have a little intermittent problem. They work sometimes, sometimes they don't. When they don't want them to, they don't work. Okay, so anyways, I wanted to put a lunar impact up there. With the perfect roundness of this shape, I put a imbrium up there because if you look at the moon, it's like a perfect circle on the moon. It's one giant impact on the moon. So if you look at it, it's like a third of the size of the moon. Let's just go look at that real quick. Imbrium on the moon. Okay. If you look at it on the moon, it's a perfect circle, one big perfect circle. And it's 1/3 the size of the moon, pretty much. 1/3. Here it is, right here. Right in the center. Right here. It's more than a third of the moon in size. So, they say, if they say that the moon is 1/4 the size of the Earth, right? 2,000 miles across, somewhere approximately that size. But they say it's 1/4 the size of the Earth. And if it hit the Earth, it would destroy the Earth. It would just totally destroy the Earth, right? Well, what about the moon? Something 1/3 the size, 1/3, not 1/4, 1/3 the size hit the moon. This is one impact. It's a perfectly circular pattern, and it's one impact. That one impact should have destroyed the moon, but it didn't. It did not destroy the moon, because actually, in reality, the moon is bigger than the Earth, and this is a print from hitting the Earth, right here. Okay, it's just a little bit bigger than the Earth, not much. But it's just a little bit bigger, and this is from hitting the Earth. This pattern, you will find this pattern on the Earth. I guarantee you reverse this image, you will find this pattern on the Earth, in the weather, on the land, wherever. You will find it, and it's at the North Pole. You can see the shapes. See this whole area right here. You can see that in the Arctic Ocean up there at the North Pole. I'm going to show you right now. Just remember this shape right here. Look at this shape. See this? See the pattern right here? This right here? You can't miss that. I mean, once you see that on the Earth, you'll know. I mean, it's pretty distinct. So here you go. Let me show you up here at the North Pole what I'm talking about. We're up by the North Pole. Okay? You see the ocean floor right here? See this area here? This where it comes down to a point right here, and it kind of goes around Iceland right there. Okay. Okay, with Greenland right in the center pretty much. So when I show you this over here again, bring this one back up again. Okay, now this is not to scale, this is oversized just slightly. And here you got, let me try to show you around it here. This is the Hudson Bay. This is Alaska right here. Okay, you got Greenland right here. All right. So this big circular pattern is just right over all that area right there, and you can see that it's a circular pattern. It's not. Now they say that I've had people tell me that the circular shapes on the Earth that are all over the place. At this same size that you see this circle right here, which is oversized, but if I was to make it the right size, it would be the same size as the rest of the circular prints on the Earth. And they say that's because it was at the pole at one time. Well, this is not centered at the pole at all. So why is it circular right here and not circular right around the center of the Earth? Okay, so anyways, let me bring up Imbrium here. Let's just go through it. Okay. So first of all, what I noticed, it took me a while to get this lined up to where I thought it fit pretty good. I mean, it's not perfect, but it's pretty good. Everything seems to fall into place anyways. Now this pattern that I mentioned right here, I can see it's not over here by Iceland, but I can see it in the weather right here. See the weather right here? See the shape? The weather comes down to a point right here. And it's not right over the top, it's just right in the same, see that? Look over here how this edge comes up right here. You can see that same line right there. You see that line, and you can kind of see right here the center of it. This isn't, I'm starting off with the hard to see stuff first, and then I'm going to show you the easier stuff. But you can see the pattern there. Okay. Then you come down like this. You go over to where Iceland is. Iceland is right here, and you see that big crater right there, that big bright crater is right in that area. It's not right over Iceland, but it's right in that area. And I did take that crater, a close-up of that crater, and I did put it over Iceland, and it does fit there.
If I'm going to show you that in a minute. Okay, so there's that. Then you got Kepler, and this area of Kepler down here at Newfoundland, where we know we have a good fossil record of something happening there at some point. Right there. Okay. See where the bright spot, where that radar was, and see where that bright spot is right there? Okay, that falls really well into place. Okay, so then you got Copernicus right below the Hudson Bay there, and you can kind of see a pattern there starting to take shape. See the blast pattern of Copernicus? The way that this comes, all these rays come out of it like this, in this direct, they go a certain direction, like there's a blast pattern there. And you can see how it kind of clears that area. But anyways, over here, this is the part that just confirmed it for me, basically. See this clearing in the weather? A nice little clearing with this radar return right there and all that. This is just a little bit off, but you can see that that's the same thing. See the shape of it? See the shape of that? And you see this line come. I mean, it needs to be down a little bit, but I can't move it to where it's going to fit everywhere. But you see the pattern really well. Look at this part right here. See this line that comes around right here? See that line in the weather right there? And then check this out right here. See, you can see like the weather shows so much. It takes practice looking at it, but you got to understand when you see so many things fit that well, and they're really close to being right in place. You just have to understand what's going on here. Like, see this shape right here, and see the pattern of that area right there. Look at this radar return right beside it right here. Now see how it curves outwards, and you got all this radar return right here. See that? Look at the pattern right there. It's the same thing. That is the same thing. They hit it. That hit. This needs to be. This edge right here should be down, right where this edge is right here, for it to be perfectly aligned. But it's hard to do that. See a little curve right there in that area. See that little line? Something right in there. Up here somewhere. See that area right there? It's probably that right there. But anyways, I thought it fit pretty good. Mirror beam right there. It always faces the Earth. It's always facing the Earth, this side of the moon. Yeah. So anyways, let me show you the Iceland thing, just so you can get an idea of what I'm trying to show you here. So, go find Iceland first. Take it a ways. Phone's getting asleep. Okay, so here's Iceland. It's just there just because I'm using it as my canvas, basically. But I was using it for something else, in another alignment. But anyways, there's Iceland, and let me just bring up that crater, which is somewhere right here. Right here. There's Kepler right here. You get a different view of it here, different angle. Okay, so what I lined up with Kepler on, or not Kepler, this isn't Kepler, this is that other one, I can't remember the name, it starts with an A. Anyways, the center, I lined up the center right here, that bright spot right there with this black spot right here, this volcano right in the center of that, right there, right? Now if you look around this area, you see a circular shape right around the outside of that volcano right there. You see this big circular pattern right here, right? Bring this back, you see the same circular pattern right around the center of that, or the outside of this bright spot. Just take a look at the pattern, if you can see it. You can see some similarities there with the blast pattern. You see this like area that blasted out right here. You can see something right there. Look on the Earth right there. You see something this direction. Anyways, that could be just coincidence, right? But then you go like this. Look at it at a different angle here. Let me show you this other part. It shows that it's not perfectly aligned, but it shows something here. This area of this crater has this line right up here. See this bright spot with this curve right there? See that curve? Okay, that goes right here.
this bright spot right here goes right in that little corner right here. Watch. And then you got the curve. You can see the curve right here. Here's the curve. And then the bright spot goes right there. But you got the same curve. It falls right into place. And it goes right there. You see it. Just moved it down a little bit. I just do a little readjustment. But you can see what I'm talking about. That bright area goes right here. And that curve follows this curve. It just falls into place that way. So it shows that it's a good possibility that Imbrium did hit that area of the North Pole on the Earth. As we can see, we got a big circular pattern up here. There's many impacts up here. I do believe you can fit many different areas of the moon at the North Pole. I've done it before, showed it in other videos, and I don't want to make this video too long, but remember Building 7, take a look at that, take a good long look at that, download that image off the internet, and just look at it a little bit. You'll discover that somebody brought that building down, and they said pull it, and they decided to pull a building, and so they did. That's what he meant. They pulled it all right to the center in a nice little pile. So everybody have a good day. Never forget that. All right.